the protein estimation by Bradford method. Let's have understanding of the principle of this method. The procedure is based on the interaction of dye, C brilliant blue, with protein. The unbound dye has an absorbance maximum of 465 nanometer. On interaction with protein, the dye turns blue and its absorption maximum is shifted to 595 nanometer. Thus, from the absorbance at 595 nanometer, the amount of protein in a sample solution can be quantitatively estimated. The Bradford assay is linear over a short range, typically from 0 to 200 microgram per ml, often making dilution of a sample necessary before analysis. It is also inhibited in the presence of detergent. Much of the nonlinearity stems from the equilibrium between two different forms of the dye, which is perturbed by adding the protein. The Bradford assay linearized by measuring the ratio of absorbance 595 over 450 nanometer. What are the requirements for this method? That is, first, obviously the Bradford reagent. How to prepare Bradford reagent? Dissolve 100 mg of C brilliant blue G2PF250 in 50 ml of ethanol. Then add 100 ml of 85% phosphoric acid and make the volume 1 liter with water. Second requirement is 0.1 molar phosphate buffer, that is of pH 7.5, and standard protein solution, that is generally bovine serum albumin. How this Bradford reagent looks when the proteins are not mixed? It gives a brownish color, you can see in the diagram. And what happens, how it changes the color when the protein is added? It gives blue color in the presence of protein. Now let's try to understand about the procedure. What we are supposed to do in the procedure: pipette approximately a liquid of bovine serum albumin solution containing 0 to 15 microgram protein. Make the volume to 1 ml with 0.1 molar phosphate buffer in all the tubes. Add 5 ml of Bradford reagent to all the tubes and mix thoroughly. Record the absorbance at 595 nanometer against the reagent blank. Plot a standard curve of absorbance at 595 versus microgram of the protein. Determine the protein content in the sample extract from the standard curve. Calculate the amount of protein per ml of the sample. Okay, this is a brief overview of the procedure. Now let's try to understand what actually happens. You are supposed to take 8 test tube. One you mark it as a blank and rest, that is 1, 2, 3, 4, 5. That is for the preparation of standard curve, and the unknown 1 and unknown 2, that we need to mark as U1 and U2. After properly marking, add the protein standard solution in each tube. Obviously for blank there will be no protein solution we are supposed to add. Then in test tube 1, 2, 3, 4 and 5 you are supposed to add 0.2 ml, 0.4 ml, 0.6 ml, 0.8 ml and 1 ml of protein solution, standard protein solutions, and then make up the volume with the help of buffer solution. In unknown 1 and unknown 2 you can take any aliquot of your choice. Okay, for a set of an example I have taken 0.2 and 0.4 ml of the protein standard solution. Then I have make up those volume with the help of phosphate buffer, that is 1 ml. After this, now add Bradford reagent in the all tube. That is 5 ml of Bradford reagent we need to supposed to add. Then mix it properly and take the OD at the respective nanometer within 15 minutes. Record your data in the table. When you observe the test tubes, it will give the color in increasing order. You can see in this diagram, okay, the color intensity of the blue color increases. The real image is shown at the bottom, where the color increases is very well judged. After getting the absorptions from every tube, then plot the standard curve. On one side keep the absorption and another side concentration of protein. You will get the straight line. From this standard curve, you can estimate the amount of protein in the unknown sample. The absorption of the unknown sample has to be plotted on the graph, and its correspondence concentration we need to find out. So that is how we are estimating the protein with the help of Bradford method. Thank you very much. These are my references. That's all.